Here's example 2 of using the law of cosines. So we want to solve triangle ABC given little a is 2, little b is 3, little c is 4, and we want to round to the nearest hundredth. So this is an SSS triangle, right? We're given all three sides, nothing about the angles, so it's an SSS. So let's just go ahead and jump right in here. And so we don't really need to draw a picture because we can tell right off the bat it's SSS, just three sides. So we're just going to use the law of cosines. Okay, the law of sines will not work to start the problem, but we can start it with the law of cosines. So let's say c squared equals a squared plus b squared minus 2ab cosine angle c. Why am I starting with that one? Remember there's three formulas for the law of cosines. There's this one, and then there's a squared equals b squared plus c squared minus 2bc cosine a, and the other one for b squared equals a squared plus c squared minus 2ac cosine b. We could use any of the three, okay, but let's just start with this one here. So c is 4, so this is 4 squared, equals a squared, which is 2 squared, plus 3 squared, minus 2 times AB, A is 2, B is 3, times the cosine of angle C. So we're going to find angle C is what we're going to do. So this is 16 equals 2 squared is 4, plus 3 squared is 9. 2 times 2 is 4, 4 times 3 is 12, so this is minus 12 cosine of C. Okay, so then 16 equals 13 minus 12 cosine of C. So subtract 13 from both sides. 16 minus 13 is 3. So this is 3 equals negative 12 cosine of C. So then divide both sides by negative 12, and we get cosine of C equals negative 3 over 12, which we might as well just simplify. That's negative 1/4. Okay, so now we can just say, okay, C equals the inverse cosine of negative 1/4. Okay, now it's okay just to do that because we know we're talking about a triangle, so and also remember with the law of cosines there is no ambiguous case, so we don't have to worry about doing any 180 degrees minus this and that like we do with some special cases of the law of sines. But for the law of cosines, no ambiguity there. So if cosine of C is negative 1/4, then C is the inverse cosine of negative 1/4. So let's go ahead and see what that is. So we'll pull out our calculators. We'll zoom in here. Then we get inverse cosine of negative 1/4. Make sure that we're in the degree mode, not the radian mode, because we're dealing with degrees. And losing focus there. Inverse cosine of negative 1/4 is about 104.4775 degrees. So we're only supposed to round to the nearest hundredth for our final answer. But along the way, let's keep 4 decimal places in case we have to use these approximations to get other answers later. Because like we always say, we don't want to use approximations to find other answers, but if we have to, let's keep more decimals than we need in the end. So C is approximately 104.4775 degrees. Okay. Now, let's also get angle A. Let's get angle A the same way. So now, since we have, let's sketch a triangle real quick. So this will be 2, that's side A, so this will be angle A. This will be 3, so this is angle B, and this will be angle C, so that's 4. Okay, so 2, 3, 4, little a, little b, little c, and the corresponding angles across from them. So we just found out that C, so picture is not to scale, 104.4775-ish degrees. Now from here we can use the law of sines to get this guy or this guy. We can use the law of sines because we have all three sides and one of the angles now. So we can do the law of sines, but let's not. Let's just get more practice with the law of cosines. So let's do it one more time, then we can get the third angle in an easier way. So we'll do the law of cosines one more time just to get more practice using it. And when we do that, let's use that for A. So A squared equals B squared plus C squared minus 2BC cosine of capital A. Okay, so little a we're given as 2, so that's 2 squared equals 3 squared plus 4 squared minus 2 times 3 times 4. Okay, little b is 3, little c is 4, times the cosine of A. So capital A is what we're going to find now. 2 squared is 4, 3 squared is 9, 4 squared is 16, 2 times 3 is 6, 6 times 4 is 24. So this is 4 equals 16 plus 9 is 25. We have minus 24 cosine of A. 4 minus, so subtract 25 from both sides, 4 minus 25 is negative 21, and then this equals negative 24 cosine of A. Okay. Divide both sides by negative 24, then the negatives cancel and we have 21 over 24 equals cosine of A. So let's rewrite that as cosine of A equals 21 over 24, but of course we can simplify that. Cosine of A, so pull out a common factor of 3. So if we pull out a common factor of 3, then this becomes 7 and this becomes an 8. So it's 7 divided by 8. So then A is equal to the inverse cosine of 7/8. And that's what we can toss into our calculator. And let's see what that is. So again, make sure we're in degree mode, and we want the inverse cosine of 7 over 8, and that's approximately 28.9550. So again, keep it out to 4, really losing focus here. Keep it out to 4 decimals until we get everything, then we can round it off to 2 in the end. So 28.9550 degrees approximately. Okay, so A is approximately 28.9550 degrees. Okay, so we have this approximation for A, this approximation for C. Now to find angle B, we could use the law of cosines a third time, but that would kind of be overkill. I think maybe we've got enough practice with that for now, so let's get rid of all this, and to find angle B, we'll just do what we always do when we have the other two angles. We say A plus B plus C equals 180 degrees. C, whoops, 104.4775 approximately degrees. A we have is 28.9550 degrees approximately. B is what we're trying to find now, and then C is approximately 104.4775 degrees. Now, since we tossed the approximations into here, maybe we should just say approximately equals, whatever. Now we just subtract these two guys from 180. So go back to our calculator. And then what we say is 180 degrees minus 104.4775 minus 28.9550. And that's about 46.5675 degrees. So now B is approximately 46.5675 degrees. Okay, so now that's pretty much it. So now to round let's put our final answers all together, and then we'll round to the nearest hundredth now since we're done. So capital A was approximately 28.96 degrees, we'll say. 28.96 degrees. Capital B is approximately 46.57 degrees. And then capital C is approximately 104.48 degrees. Okay. Okay, so that's it for that. Now, I do want to point something out. What happens if we add up all three of these? So let's add up all three of these rounded answers here. So A we had was 28.96, and then we're adding to that 28.96, then plus 46.57 degrees, plus 104.48. So notice they all add up to 180.01, right? So if you add up all three angles in a triangle, it should be 180 degrees, but here we have 180.01. And just want to point out, that's the type of thing that could happen when you deal with approximations. So even though we rounded out to 4 decimals, when we use these approximations to get this other angle, so we use the approximation to get angle B, right? But you know, even if you round out to 4 decimals, this type of thing could still happen. So that's just want to point out that sometimes this numerical type of round off error just can't be avoided. Anyway, that could happen. So anyway, it's just a good habit to get into, keeping more decimals than you need until the very end, because that will at least minimize the error. Okay, if we kept less decimals along the way, we probably would have an even, a number that's even farther off from 180. So anyway, that's it for example 2 of the law of cosines.